In the last video, I showed you how to create this password protected puzzle using the Chia Lisp high level language. And then we went to the command line and curried in the password, and we ran run using this puzzle that we created with curry and the solution. And everything looked fine. We did a 51, which is to create a coin, and it went to Alice, and it was 1,000 mojos. Great, but we didn't actually put this on a blockchain. We just put it on my laptop. So let's create a transaction now and push it out to the blockchain so you can see how this actually works. Okay, back to the IDE, and I'm going to create a new file here, and it's going to be called spendbundle.json. And a spend bundle is Chia's term for a transaction. And normally you're going to have Python or some other language creating this for you automatically, but I'm just going to show you how to do it manually for now so you can see what goes into it. There's two things at the highest level: coin spends, and you need a square bracket, and then a comma. And you can have more than one coin if you want. That's why they're bundled together, and it's called a spend bundle. The other thing you need is an aggregated signature, which I'll get to in just a minute. And notice how that's outside of the coin spends. That's because you only need one signature per spend bundle. So you sign them all together, in other words. Okay. We need another set of curly braces, and then there are three things that go into a coin that we have to reveal here. And three things that you have to reveal in order to do a transaction. One is the coin itself, and there's more to put in here. I'll come back to it. Two, you have to reveal the puzzle that you created in byte form. So that's called a puzzle reveal. Okay, I'll leave that blank for now. And the third thing is a solution to the puzzle, which we already did on the command line. Okay, that's also blank. Now, what I was saying before is what goes into a coin itself. There's three things that make up the ID of the coin. There is the parent coin info. There is the puzzle hash. And there is the amount. And these three things hashed together are what make up the coin itself. So this is all we need to create a transaction with a single coin in Chia. This is a good skeleton for what we're doing. And I'm going to fill in a couple values right away because we know them. We know the amount is 1,000. We already did that. The aggregated signature is also going to be easy for this one because we're not going to use an aggregated signature. This is the BLS signature for the entire spend. And you cannot just leave this blank, even though it's optional to use it or not. So I'm copying the default value and I'm going to paste it right here. It is 0x for bytes, the letter C, and then I think it's 191 zeros. It's a lot. I would not recommend trying to type out the exact number. I'll put a copy of this along with the video so you can just copy and paste it for yourself. And by the way, later I'll show you how to make a real aggregated signature once we start getting into the legacy puzzle itself. Okay, there's a few things that we can figure out right away. First of all, I've already tested this using this password test, so I want to make a new password. So let's do that now. Run SHA-256. Let's just write, I don't know, Chia is good. Okay. What does that give us? Okay, so that's our hash that we'll use for the password Chia is good. I'm going to curry that using the new hash. Okay, I'll replace this old password hash with the password test with this new one. Okay, so this is going to give us the puzzle itself in CLSP format. But I could just swap out or add on another flag called -x, and that'll give us the bytes for this puzzle. And this is the puzzle itself in byte format. So when you go to spend a coin, again, you need to reveal the coin itself. You need to reveal the puzzle and the solution in order to spend it. I'm going to copy this. This is the puzzle. So let's go back to here, paste it. And what's the solution that we're using going to be? Well, we used, up here we used Alice and 1000. Well, 1000 won't change, but this is not a real puzzle hash. I need to get a real puzzle hash. So I'm going to go onto Chia here. And this is my wallet that I created for testing. Here's the first receive address. I could even give myself a new one. Why not? So there's a new receive address. Copy it. And I need this, right now it's in TXCH format. It's an actual wallet address. I need the puzzle hash instead. So there's a command I can use to change it. So that is cdv decode. Pass that in. And that'll give me the puzzle hash for my wallet. And this is pretty cool because the puzzle hash and the wallet are one-to-one. It's directly translatable. So I'm gonna do copy that and do a command called opc, and I'm gonna pass in the solution. So this was my old solution, right? I'm just gonna make a new one that's using these new values, and instead of Chia test, we did what? Chia is good for the password. Okay, and I need this new puzzle hash, and this is very important. I need to enter 0x because this needs to be interpreted as bytes. So 0x, put in the puzzle hash, and the amount was 1000. Okay, so that's the solution to our puzzle. opc translates it into byte format. There we go. We can copy that and enter it into here. Okay, what about the coin itself? Well, here's the thing that is very interesting about Chia, especially once you wrap your mind around it. I'm going to go, instead of doing this x command, which I did before, which gave me bytes, I'm going to change the x to 2 hyphens and tree hash. That gives me the tree hash of the puzzle. Okay, so do you see what's happening here? This is the code. If we go back to the IDE, this was the code for the puzzle, but this becomes the coin. So I compile this, or I get a tree hash for this code, and all a tree hash is, I mean, I'm going to oversimplify this, but a tree hash is taking the code that I had before, which can be displayed in a binary tree format, and it's hashing each of the leaves of the tree, and then it's hashing them all together, which gives me a tree hash. So that is the coin. The coin is the code. The code is the coin. That's what they mean when they say everything is a coin, and that's what they mean when they say this is magical programmable money. It truly is, and it's really remarkable that it works this way. I'm very impressed. Okay, so here's the tree hash. I might as well just paste this in right away, but there's a couple more things I need to do. So go to the Spendbundle. There's my puzzle hash. Here I do not need the 0x, by the way. I still need the parent coin info, which I don't have yet because I haven't actually created this coin yet. So how do I create the coin? Okay, I need to take this tree hash, and remember how before I went from a wallet address, which was, where was it? Right here, to a tree hash. I need to go the other direction, a tree hash to a wallet address. So I'm going to go cdv encode this time and put in the tree hash, and I need to put in a prefix because I'm on the test net. The default's going to be XCH for the beginning, 3 of before the puzzle, the wallet address, I need to make sure it's TXCH because I'm on the test net. Okay, there we go. So this is the quote unquote wallet address of this puzzle that I just created. So I'm going to send a coin, back to the GUI and send a coin to this address, just like I would send it to another person. This, for anyone who's looking at this, who doesn't know what I just did, they could see this address and think, oh yeah, that's another human, and that's their wallet. But in fact, it's actually a smart coin. So I'm sending it there, and remember the amount was 1,000 mojos, so I'll put 0.1, and then luckily it shows you how many mojos you're talking about here. So you need a bunch of zeros, and you need to get this right, but it's easy to do because now this is displayed. 1,000 mojos and no fee. I'll send it. Okay, it's been added to the mempool, and the outgoing transaction is pending. So I need to wait for that to appear. And the last thing I need is that parent coin info. So the way to get that is to look at the blockchain itself. And here's the command: cdv rpc coin records. And I'm going to go by puz hash because that's what I already know. And this was my puz hash for my coin. Okay, and I might as well throw in -nd for name dict, which will give me one more value that I don't quite need yet, but still is nice to look at. Okay, you see it's empty, and that means that no one else has created this exact same puzzle and put it on the blockchain. And I'm still waiting for that transaction to confirm. So I'm going to go back to my GUI. And sometimes this takes a couple minutes, so I'm going to pause the video here and wait for this to finish. Okay, it took a couple minutes. It switched over to confirmed. On the testnet, I find it takes a little bit longer for the transactions to clear than it would on the mainnet. And now we're going to go back to the command line. I'm just going to run the exact same command again. Okay, I'm going to do RPC coin records by puz hash, name dict. And here we go. Now we have a coin. This is the ID of the coin. And the way you get the ID, again, is by hashing together the amount, the parent coin, and the puzzle hash. So that is, it's figure outable, if you will, from these three values. Okay, it's not a Coinbase, so it wasn't a farmed coin. We know that much. We know when it was confirmed just now. It has not yet been spent. So once this goes to true, once you spend it once, in other words, then it's done. You can never spend it again. And you get the spent block index and the timestamp for when it was created. Okay, so the thing that we were looking for before was the parent coin info. And again, I don't need the 0x part for the spend bundle. So I'm going to copy the rest of it back to the IDE, parent coin. And you'll notice that the puzzle hash I already filled in. That I could figure out before putting the coin out on the blockchain. Starts with 589 and this starts with 589. Great. So now the spend bundle is complete. I have every single value that I need. And before I push it to the blockchain, I'm going to just test it out here. So cdv inspect spend bundles. Okay, and I'm going to put in my JSON file -db for debug. This shouldn't give me any errors, hopefully. This part is just for the signature. This part shows me where I'm going to create the coin. And, oh yeah, by the way, I didn't say I'm going to send the coin. I guess I did kind of say, but just to make it super clear, I've put this coin on the blockchain. It's sitting out there. It's locked up. Anyone can see it. Again, you could have run this, here, let's run that again. This coin records command, you could have run that from anywhere. You didn't have to be on my computer. You can see the coin there, but you don't know how it is locked up, and you also don't know how to unlock it. So it's sitting there. If you made a mistake, or if I made a mistake, then I could be unable to lock this coin forever and ever. But luckily, I do know how to unlock it. And what I'm going to do when when I unlock it, is send it back to my my wallet that I just used to create the coin. So the coin is gone now, right? Let's just to be super thorough here, we did outgoing. It's confirmed. It's 1,000 mojos, and now instead of having 200 here, I have 199,000 mojos left. I'm going to send this coin back to my SAM wallet, so it should come back in. And the inspect command worked. So the final command that I do to actually push the transaction out is cdv push cdv rpc, sorry, push tx and the spend bundle. Let's see if that works. Great, it was successful, and success is true. If something went wrong, I would get an error here. I still need to wait a couple of minutes for this to get confirmed, but eventually this should pop up as incoming and 1,000 mojos. And just to be as thorough as possible, I'm going to wait here until this finishes and pause the video. Okay, this time it didn't take nearly as long, and we have an incoming transaction that's been confirmed. I now have 200,000 mojos in my wallet, which is fantastic. Okay, so now you know how to create a password protected coin and push it out onto the blockchain where it's locked up until someone can reveal the puzzle and the solution, and they need to have that password in order to unlock it, and then you can send it right back to yourself or send it somewhere else if you want. So this is a good foundation, I think, for learning Chia Lisp, and in the next video we'll get to the meat of this tutorial, which is the Leave a Legacy coin. See you then.